Welcome to another episode of Liineman Talk. The goal of this channel is to share the utility experience, the lineman experience, the work that we do every day. I made lineman in '84, and if you don't want to be in the Army as an 11B, working for an electric utility is a good way to make a living. There's lots of good jobs. Today we're going to spend some time talking about transformer calculations and shortcuts that we've learned along the way. Electric math is pretty easy when you learn the formulas. You can do math from the transformer to the load and from the load back to the transformer. The conventional transformer that we hang every day to serve a residence is built with a primary coil and then a secondary coil that looks like this. So from here to here is 240 volts. From here to here is 120 volts. So we have 220 volt coils that are in series to make the 240. So if I have a 10 kVA transformer, it's built with a 5 kVA here and a 5 kVA here. And that's important to you when you start sizing the transformer. We know that the math that gets taught at transformer school for the calculation to determine how much current can a transformer do at 100% rating is the 10 kVA transformer that we hang every day, 10 kVA, that math is 10 times 1,000 divided by 240 volts. In our case, 240 volts. Now, if you do that math, you're going to see the answer is 41.66 amps. Now, the shortcut that we teach is take your kVA number, multiply it by 4 at 240 volts, 250 volts, and the answer will be 40 amps. 10 kVA, 40 amps. And if this 1.66 is the deal breaker, you have other problems. Let's do a 25 kVA transformer. 25 times 1,000 over 240 is 104.16 amps. If we take the 25, multiply it by 4, the answer is 100. One more time, how important is that? All right, now we're going to move into three-phase calculations. In most utilities, the transformer banks that are offered are a Y secondary 208/120 volts, 240 volts, 120 volt delta three-phase. That's where we have a high leg. And then we have 480 volts, and that can be in Y or delta. In the old days, we built a lot of 480 volt delta with a grounded corner. Today, most of our 480 volts is delivered Y 277. 277, 480 phase to phase. The three-phase math that they teach you, we talk about a three-phase transformer bank, we add all the kVA together. So if I have three 100 kVA transformers, I have 300 kVA. If I have a 300 kVA pad mount, he's built with three 100 kVA coils. So the math is take your kVA, total kVA times 1,000 divided by the phase-to-phase voltage, this is phase to phase, times 1.732. 1.732 is the three-phase multiplier. When you're 120 degrees apart, which is three-phase transformer banks in the United States are 120 degrees apart, you're going to see voltage times 1.732. Okay, so if I have 480 volts times 1.732, the answer is 831.36. So let's pretend that we're doing the math, the output math, at 100% rating for a 100 kVA pad mount. So that 100 kVA pad mount's going to have 3 coils, 33.3 each, totaling 100. So we'll come up here and we'll fill in the blanks. 100,000 divided by 831.36. Now you're probably doing that math in your head. My number at 480 volts is 120.28 amps. In this shortcut that we're going to show you here in just a second, my off the top of your head, 120 amps. And you already know how I feel about this part right here. If that 1/4 of an amp means anything to you, I don't know how to help you. All right, now let's go into those shortcuts. 3-phase calculation shortcuts. Earlier, I told you that we had 3 secondary voltages, and they are 208, 120, 240 volts, 120, and 480 volts. If it's delta, it's 480 volts. If it's Y, it's 480 volts, 277. The shortcut, all you need to know is the size of your transformer bank, the secondary voltage output, and the multiplier. All these are in your head. So we're going to go to a transformer bank that is 100 kVA. The multiplier at 208 is 2.8. So if I tell you the ampacity of the 100 kVA transformer at 208 is 280 amps, I'm only 2.5 amps off the long math. So that multiplier is kVA times 2.8. Now we'll go and do 240 volt delta. Transformer bank is still 100 kVA. We know that the phase-to-phase voltage output is 240 volts. 100 times 2.4. I tell you the capacity of that transformer bank at 100% is 240 amps. The long math, 240.56. So we go back to the formulas. We show you that at 240 volt, it was kVA times 2.4. This works 100% of the time. Now we'll do 480 volt, and I don't care whether it's Y, delta, grounded corner, doesn't matter. Phase-to-phase voltage is 480. The multiplier will be constant. So we're going to go and we're going to have that same 100 kVA transformer bank. and the multiplier at 480 is 1.2. So I have the 100 kVA transformer bank, and his output is 120 amps. I do the long math, I get 120.28 amps. If I'm on a 25 kV 14.4 line and I measure 23 amps on one primary leg of a 3-phase balanced load, 23 primary amps equals 1 MVA. So if you've got an amp meter, you go up and you straddle the primary, you can turn those amps into MVA. I've been using these formulas for many, many years. So hopefully this works for you. I know some engineers that want to do the long math because this can't be right, but I guarantee you every time it will be right. So thanks for watching. I'll see you next time on Liineman Talk.